Hey y'all, let's cover linear review for exam one. So this is the first part. There's going to be a second part, and I am going to make two different videos for this. Here's the deal. If you're watching this and you have not completed your review for exam one, you are not to do this with me. You should have already gone through and completed this. And this, you're using this video to check your answers and look for anything you don't understand. This is not a lecture. This is not the time to be learning how to do this. This is just your reviews you need to use to make sure that when you sit down to my exam, you could answer all of these questions using what's on your 3x5 note card, your calculator, and your writing utensil. That's all you're going to have access to. You're not going to have your notes, and you're not going to have me there to support you. So this is the time that if you haven't done this, work these problems, pause the video, even if you have to do that, work the problem, then push play to see if you answered them correctly. Okay. Do not use this as a lecture. That is not what this is intended to be. This is me sitting down, doing the review after you've already completed it on your own. Okay. So let's keep going. I'm going to show you how to answer these for my exam, what I'm looking for. This one, the majority of people get it wrong on my exam because they don't answer the interpretation properly. So a function d of h gives the number of miles that Billy has driven in his car from his house h hours after leaving his house. Okay, so the h inside of here is hours after leaving his house. All right. The d of h, the entire function, is the number of miles that Billy has driven. Okay, so if it says d of 4 is equal to 160, that means, well, the 4 is 4 hours after leaving his house. So this is A, 4 hours after leaving. I can write nicer if I'm looking at my words. His house. Billy drove. And now's where we put the function part in here. The d of h is the number of miles Billy has driven. Billy drove 160 miles. And you need to make sure you put the proper units that's being represented here. So we've got 4 hours. Hours is a unit for the 4. And then we have miles for the 160. Let's look at B. Interpret d of 0.1 equals 2. Well, what is 0.1 if it has to do with hours after leaving his house? How do we do that? Well, the 0.1 means that he's not even gone for an hour. He's gone for 0.1 of an hour. So what's 0.1 of an hour? Well, we have to know that minutes make up an hour. And we have to know that there are 60 minutes in an hour. So you're going to go 0.1. Let me do this here. 0.1 times 60 minutes. And that's equal to, 0.1 times 60 is 6 minutes. So my interpretation here would be 6 minutes. Goodness. After leaving the house, after leaving his house, Billy drove. That's what the d of h is, the number of miles. Billy drove how many miles? 2. He drove 2 miles. 2 miles. All right. Those are my interpretations. The function g of t is given by the table below. And it wants us to evaluate g of 1. So whenever I explained this initially, I said you need to understand that g of t is the function. And g of 1 means that they're asking us this question. When t is equal to 1, what is the function? What is g of t? So when t is equal to 1, what is g of t? It's 24. All right. So g of 1 is 24. That is the answer. Evaluate g of 6. This is A. B is g of 6. The same question. When t is 6, what is g of t? So when t is 6, g of t is 3. And those are the questions I'm asking myself. When t is 6, what is g of t? Now for the next one, it's going to give you determine t. So we're going to be looking for our answer up here when g of t is 24. So they're telling us, I'm going to write g of t is equal to 24. When I see this, I say, okay, when g of t equals 24, what is t? Okay, so when g of t is 24, here it is. What is t? T is 1. So g of 1 is 24. But there's another 24 where g of t is 24 and t is 3. So g of 3 is also 24. If you didn't put in function format, that's okay. But the other thing you would have to write instead is you would need to either provide this for your answer, or you would need to say that t is equal to 1 and t is equal to 3. I would accept either one of those sets of answers. Okay, I don't require both, just one, just to represent. Okay, let's look at number 3, and this is going to be using our graph of a linear function, and it wants us to evaluate f of 0. So remember, this is your x value, and this is your f of x, or your y value. All right, so if this is representing f of x, this means when x is 0, what is f of x, or y? So when x is 0, what is y? Well, you've got to find on the graph where it's at. When x is 0, it's on the graph right here. And on the y-axis, it's -2. So for A, f of 0 is -2. The next one's asking us the same thing. When x is 4, find that on the graph. What is f of x? It's 2. Okay, when x is 4, here's x is 4, find it on the graph, and then see where it hits on the vertical axis, and that is your y, or your f of x. The next one is determine, now we're going to be looking for our answer from the x-axis, determine x when f of x is -3. So they're saying that on this axis, f of x is -3. Well, here's -3. This is what it is on the graph. And where's that hitting on the x-axis? That's -1. So f of -1 is equal to -3. You could also write it like, instead of this, you could say that x is equal to -1. I will accept either one of those answers, okay? Or you could put it order pair, but we really didn't do a lot of that. And then the last one is when f of x is 1, we need to know what x is. So on this value, whenever it's at 1, well, here's 1, find it on the graph. What is that in the x value? And that is 3. So f of 3 is equal to 1, or you could write x is equal to 3. So this would be an or. All right, let me know if you have any questions on that. All right, evaluate the function. So given the function k of t is equal to -8t plus 9. The first one is k of 3. So for A, we just take k of 3. Well, they're saying that t is 3. So if t is 3, that means everywhere over here that there's a t, you need to plug in 3. That's crazy. Now, we're not solving for k. So this is just k of 3. We're only solving this expression over here on the right. We need to multiply these two numbers first. -8 times 3 is -24. And then we can add the 9. And let's see here, we've got Negative 24 plus 9 is negative 15. So your final answer is k of 3 is equal to negative 15. The next one, now we've got k of 0. K of 0, again, everywhere there's a t on the right, we're going to plug in a 0. And we're only going to solve for the right. Anything times 0 is 0. And 0 plus 9 is 9. So k of 0 is 9. And then the last one is determine t when k of t is equal to negative 39. For this one, I like to rewrite the original function. And then we're going to substitute because they are saying that k of t is negative 39. That means I can take where this k of t is and plug in negative 39 and just rewrite the rest of this. Okay, now we're going to solve for t. I need t isolated by itself, so let's get rid of the 9 first. This is negative 48 is equal to negative 8t. Then we need to divide both sides by negative 8 because the negative 8 is multiplied to t. Negative 8 divided by negative 8 is 1. So let's check our t. And then 48 divided by 8 is 6. And negative divided by negative is a positive. So our answer can be t is equal to 6. Or you could answer that k, what is it? What is I going to say here? Yeah, k of, there it is, 6 is equal to negative 39. Either one is correct. Identify the rate of change and initial value of this function. So when we're looking at a function, f of x is, remember I said it's b plus or minus mx, where b is the initial value and m is the rate of change or the slope. So b is your initial value and m is your rate of change, constant rate of change, or slope. Okay, so I'm just going to rewrite this in this format. F of x is equal to, well, it's already there. It's negative 9 minus 10x. Oh, cool. So the negative 9 is my initial value. And the rate of change is negative 10. There. It's the number in front of the x, the coefficient of x. X is not included. X is your variable. So it's the number in front of x, including the symbol, okay? The sign. So number 6, calculate the rate of change of the linear function that contains the points negative 15, 30, and 7, negative 14. And I gave you a formula for this. You're going to want to have this in your notes. Rate of change is y sub 2 minus, oh gosh, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And this is given 2 points. And they're giving us 2 points, negative 15, 30, and 7, negative 14. I'm going to just label these x1, y1, x2, y2. And then I'm just going to plug and chug. I'm going to substitute them in. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Negative 14 minus 30 is negative 44 over, this becomes 7 plus 15, because the negative times the negative is a positive. So this becomes 7, 8, 9, 10, 11, 12. So this is 22. And this reduces to, well, I know that 22 goes into both of them. Maybe you only saw that 2 goes into both, but 11 goes into both as well. So they reduce to, 22 goes in here twice, negative 2. So question is, calculate the rate of change. Rate of change is negative 2. Or you could say it decreases by 2. Either one works for me. Determine the rate of change and initial value of the linear function that generates the following table of values. Okay, we just need to have 2 points from here. It doesn't matter which ones we use. I always like anything with a 0 in it. That always makes me happy. And let's just go with something simple that, well, we can use one that has numbers with negative numbers. So these will be my two numbers. My X value is -1 and -7 is my Y, and then 0, 14 for my other point. I'm just going to label these real quick, X2, Y2, and then I can find my rate of change. Rate of change is Y2, which I have up here, 14 minus -7, because Y1, over X2 minus X1. All right, so this is 14 plus 7 over 0 plus 1, 7, 8, 9, 10, 11. So that's 21 over 1, which is 21. So the rate of change is 21. And the other question it asked me is the initial value. The initial value is, well, initial value means that it's where your y-intercept is. So it's where your x is 0. Okay. So your x is 0 here. So your initial value is 14. All right. It's where x is 0. Your y-intercept, if that helps. All right. Next one. Price of gasoline, gallon of gasoline is increasing by 3 cents per week. If the price is $3.10 per gallon today, what will it be in 10 weeks? So we need to create a linear function. And it's a word problem, so I always start off like this. So I need to know what things are. The price of a gallon of gasoline, so that's what this is. F of X is my price per gallon. And then I need my X to be my time. It needs to be my number of weeks. Number of weeks. So F of X is equal to the initial value, the initial price per gallon is $3.10. And it is increasing, they told us that, by 3 cents per week. Make sure that you put 0.3 times X, because it's not going to be 3X, because it's 3 cents. If you was just a 3, that would be going, means it's going up by $3 per week, and that's not what it is. So, and they want to know the value after 10 weeks. So F of 10, we're going to plug in 10 for our weeks. 0.03 times 10 is $3.10 plus 0.3, which is $3.40. So let's answer the question. The price in 10 weeks is, don't forget your dollar sign, $3.40. Now I'll be asking for you to write the function as well as calculating it, okay? Because I know that you could have just sat there and said, oh, well, I just need to add, 3 cents 10 times. That's not what I'm going to allow you to do on the exam. You have to write the linear function and then use that linear function to make sure that it gives you the pricing, all right? You can rent time on computers at the local copy center for $8 setup charge, an additional 30 cents for every minute. Here's what I'm going to have you do. Write a linear function for this and define your function of variable. So if we're going to use F of X is equal to B plus or minus MX. B is my initial amount, or my setup charge. And then M is going to be my varying charge based on what happens. This tells me it's 30 cents per minute. So that means that X has to be per minute. These are my minutes. And my F of X is going to be the price to rent time. This is price to rent time on the computers. All right. So F of X is equal to, it's $8 no matter how long you're spending on that computer. You're going to pay that straight up $8, even if it's for 1 minute. And then, and an additional, so plus 30 cents for every minute. So 30 cents per minute. There's my linear function. So there's my A. That would be my answer. I don't need a sentence because it's a function or an equation. And then B, use the linear function to how much will it cost you to rent a computer for 15 minutes? Well, I said X is my minute, so F of 15, I'm plugging in a 15 everywhere there's an X. All right, 3.3 times 15 is $4.50. So it's going to cost $12.50 to be on that computer for 15 minutes. So how much will it cost you to rent a computer for 15 minutes? It will cost, don't forget your dollar sign, $12.50 for 15 minutes of computer time. Again, I'm not judging the sentence, I'm judging, or do you understand what it's representing? Are you given the correct units? Are you given the correct rounding? That's what I'm looking for. Next one, you hike a 3-mile trail, starting at an elevation of 8,000 feet. All right, so we're already at 8,000. Along the way, the trail gains elevation at a rate of 650 feet per mile. All right. Create a linear model to show what is happening. Draw a picture if needed. I always draw a picture just to make sure I understand. I know this is going to be 3 miles. All right. And it's 650 feet per mile. So M is 650 feet per mile because that's what the increase is by. It's the rate. It told you what the rate was. We need to create a linear function to where what? The elevation is the f of x. It starts off at 8,000 feet and it's increasing at a rate of 650 feet per mile. So f of x is 8,000 plus 650 x, and this is going to be miles. All right. Now, that's our function, but we're saying it's 3 miles. So what does this look like at 3 miles? What would the elevation be? $19.50 be 9,950 feet at 3 miles. So it asked, does this model seem realistic? I'm not going to ask that question for something like this because you have to have knowledge of how high 9,950 feet is. So it doesn't make sense to ask you that question regarding this one. I could ask you how high, that's kind of what I'm doing here. Instead of this, I'm saying, okay, what is your elevation, the elevation at the top of the trail? At the top of the trail. Sorry, y'all. Kind of making this up as I go. And for that, you wouldn't have calculated this, but this is just something I could do. So I'm not going to ask you if this model seems realistic for something like this. If it's something that could make sense, I would, but not for this. All right. Couple more. All right. Small store sells fresh pineapples. I like this one. Based on the data for pineapple prices between $2 and $7, the store owner created a model in which a linear function is used to describe how the demand, the number of pineapples sold per day, varies with price. This will make the economics professors very happy. For example, if you sell pineapples for $2 each, then you sell 80 pineapples. If you sell pineapples for $5 each, you sell 50 pineapples. Find the rate of change and interpret what is happening. So this one, we can decide if it makes sense or not. So for $2, they're selling pineapples they're selling 80 pineapples. For $5, they're selling 50 pineapples. This gives us two ordered pairs in which we can label x1, y1, x2, y2, and find the rate of change. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 50, y sub 1 is 80, x sub 2 is 5, x sub 1 is 2. 50 minus 80 is negative 30, 5 minus 2 is 3. This becomes negative 10. All right, to interpret what is happening, first of all, that's the rate of change. So the rate of change is decreasing by 10 something. To know what this is, you need to know what are your Y values. Your Y values are your pineapples. What's your X values? It's your dollars. So this says negative 10 pineapples per $1. So the rate of change is decreasing by 10 pineapples per dollar. Okay, per dollar increase. So that's what's happening. And that's the rate of change. This means that for every dollar that you increase the price per pineapple, you're going to sell 10 fewer pineapples. Which is better? Is it better to have sold 80 pineapples at $2 or 50 pineapples at $5? Let's calculate that just to see which one's better, because I'm curious. So if I sell 80 pineapples at $2 a piece, I make $160. If I sell 50 pineapples at $5 a piece, I make $250. I want to sell 50 pineapples at $5 a piece. This is also what the car dealerships are doing as well. The new cars coming out, the people have decided, the companies have decided to charge more for the cars and sell fewer of them to make a higher profit. So this is real life. This is what happens. And this is what I'm trying to help you understand. Okay. So we've interpreted what's happening. For every dollar increase, you're selling 10 less pineapples. I'm going to write that. For every $1 increase in price, you are selling 10 fewer, 10 less, however you want to say it, 10 fewer pineapples. Is that bad? Well, we just proved it's not. Okay. It's all about the money. All right. Number 12. A couple more of these. We've got a bunch for linear functions. All right. Study of the National Institute of Alcohol Abuse and Alcoholism showed that for a group of fasting males who consumed 4 drinks rapidly, the blood alcohol content rose to a maximum of 0.08 grams per 100 milliliters. So that's blood alcohol content of 0.08, which is the limit when you start getting ticketed. About an hour after the drinks were consumed. 3 hours later, the blood alcohol content had decreased to 0.04 grams per 100 milliliters, which means a blood alcohol content of 0.04. Find a linear model that describes the elimination of alcohol after the peak blood alcohol is reached. Okay, which the peak blood alcohol is reached 1 hour after the consumption of those 4 drinks, because that's when they're at 0.08. Okay, so we're going to use that as our initial value of where they're at. And then we'll have to check the next piece. So let's create a linear function. F of x is going to be their blood alcohol content. And the x is going to be the time, hours after peak. Okay, so f of x is equal to, the initial is 0.08 right here. And are we adding or subtracting to this? So for every hour that happens, oh gosh, how are we going to do that? We need to find a rate of change. So we know that the first one, that's going to be hour 0 is 0.08. And then 3 hours later, the blood alcohol content is 0.04. We can find a rate of change. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So x1, y1, x2, y2. So 0.04 minus 0.08 over 3 minus 0. Negative 0.04 over 3 is negative what? 0.04 divided by 3 is 0.013 continuous. 0.013. I'm just going to leave it like that. All right, so I can come up here and say my initial was 0.08 and it's dropping, so it's decreasing by 0.1013 per hour. All right, so there's my function. That answers my first piece. My second one is, what is the blood alcohol content after 5 hours? Well, I know X is my hours after peak. So F of 5, I'm plugging in 5 into my X. And I get 0.08 minus 0.013 times 5. 0.3 times 5 is 0.065. And 0.08 minus that is 0.015. So your body's still not clear of the alcohol after 5 hours of hitting the peak. After 5 hours of hitting the peak. All right, so let's answer that. According to the model, what is the blood alcohol content 5 hours after the peak is reached? So 5 hours after peak, the blood alcohol content is 0.015. All right, 13. Until about 1850, humans used so little crude oil that we can call this amount 0, at least in comparison to the amount used since that time. All right, so 1850, I got a 0. 1960, humans had used a total of 600 billion cubic meters of oil. So 1960, I'm going to put 600. These are a couple of ordered pairs, it looks like. I don't even know what the question is, but I see that happen. Create a linear model that describes world oil use since 1850. Let's find the rate of change. We're assuming that it's linear. We have to assume it because we don't see anything else. It says create a linear model. So time is always your X values. So that's why I put time in my X value places. So the rate of change is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You're going to want to have that on your note card if you don't have it memorized. I am not providing you with any formulas at all. All right. So 600 minus 0 over 1960 minus 1850. And that's 600 divided by 90. 1960 minus 1850. 110 years. 600 divided by that is 5.45. All right. Without knowing what that 5.45 represents, you're not going to know whether this is valid or not. And this is a great one, the great question to ask for validity. because with a linear function, what this means is we need to understand that this is representing cubic meters of oil, billion cubic meters of oil since 1850. So for this model, that means in 1850, we're assuming they use 0 oil. And based on, if we're saying this is a linear function, that means that every stinking year since 1850, we've used 5.45 billion cubic meters of oil. So if we use 0 in 1850, in 1851, they're saying we use this amount. We didn't have enough cars for that. There weren't enough cars. There was not a surge in car purchases or availability over that 1 year period of time, much less every year since then. So this model is not valid. So what we can say is, I can literally say this model is not valid. And then you want to give a reason, because it says discuss. 0 usage, 0 oil in 1850, then 5.45 billion cubic meters in 1851 is not possible. Just give me a reason. That's it. Okay. All right, one more. Yep, last one for linear functions. I gave you a bunch because there's so many things that are covered in this. You're only going to have one of each of these types of problems, so just know that. And the next one's going to be a lot easier of a review. The price of a particular model car is $15,000 today and rises with time at a constant rate of $800 per year. We need to create a linear function for this. So write an equation for a linear function and use it to answer the question. I'm not going to tell you linear. I'm going to say write an equation for the function and use it to give an answer. You're going to need to know that this $800 per year is going to be a linear function. In fact, I'm not going to ask you to write a linear anything. You're going to need to know, looking at the problem, if it's a linear function or an exponential function so that you can write it. That is part of what your exam is going to be over. Okay, so f of x, we need to define our function and the variables. So particular price of a model car, so f of x is the price, and x is going to be per year. It's going to be the years. So f of x is $15,000. I'm going to write b plus or minus mx. So f of x, the initial value is $15,000, 2, 3, and rises with time at a constant rate. It rises, so it increases, so that's positive, at $800 per year. So there's my function. And I defined my function and I defined my variables. Good. B, how much will a new car cost in 3.5 years? Well, years is x, so f of 3.5 is equal to the 15,000 plus 800 times 3.5. 800 times 3.5 is going to increase by $2,800. And that is 17,800. Question is, how much will a new car cost in, I can't say that, in 3.5 years? In 3.5 years, a new car will cost, do not forget your dollar sign, $17,800. And then C is briefly discuss whether a linear model is reasonable for the situation described. I'm not going to do that. I'm not going to do that to you because too many other variables in deciding whether or not that could be correct. I'm not going to do that. So C is not going to be a question for you. That's it for exam 1, part 1. The next video will be review for exam 1, part 2, which will cover exponential functions as well as percentages. All right, that's it. I'll catch you in the next one.